Hi all, today's topic is path, cycle and connectivity. What do you mean by path? A path of a length n from a vertices v0 to vn is a sequence of the form. So we can write it as v0, e1, v1 and e2 etc. So path means how it will be means, for example, like this. So one vertices, then corresponding h1, then second vertices h2 and third vertices h3 and fourth vertices and h4. So this full form is called as a path. Okay, so v0 is nothing but initial value and vn last v4 is the terminal point. So length is nothing but number of the edges appearing in a path is called as a length. Always you can remember the loop is not a path. Okay, the loop, whatever it is a loop, when you get, it's not a path. Connected set. A graph is connected. When it is connected means if there is a path between every pair of distinct vertices of the graph is called as a connected. Cycle. So when we say cycle, so the full form is called as a cycle. The cycle is V1 E1, V2 E2 and V3 E3, V4 E4 and V1. So it is a full cycle with respect to the length is nothing but 4. So the length is nothing but 4. So another one more special case is a null graph is totally disconnected. So it will be a disconnected, it will not be a connected. So connected graph means there will be a connection between. So this is the example for connected graph like a star. So two theorems are there. We will not be using the proof for this. So only the statement you have to learn. If the graph G is either connected or not have exactly two vertices of odd degree, then there is a path joining these two vertices. Okay. So when we have exactly two vertices which is odd degree means there will be a path joining two vertices. The maximum number of the edges in the simple disconnected graph with n vertices have and k component, then we can write it as n minus k into n minus k plus 1 divided by 2. We can write it. The maximum number of edges calculated by this. Okay. So related to this some problems. The first problem, find the number of the edges and degree of each vertices in each vertices in a complete graph K5. It has been mentioned it is a K5 graph. So K5 graph is nothing but 5 vertices. K5 means it is a 5 vertices. So the number of the edges. So formula we have it. You remember this formula, number of the edges. When I do complete graph. So you don't remember means you have to check my previous video. It's nothing but so 5C2 is the for a complete graph definition. In that video you refer my video, then you come and check this in this videos and it will be very clear. So 5C2 is nothing but 5C2 is nothing but 10. Okay, so the number of the edges is nothing but we need not calculate at all. So directly 10. So the degree of each vertices is nothing but so degree it can be calculated. So 5 minus 1 is the degree calculation. So it is nothing but degree only it is we need to calculate. Number of edges calculated degree. So the degree of each vertices is nothing but 5 minus 1 it's a 4. So completed. The second question. Can a simple graph with 8 vertices have a 40 edges? We have to check whether it has a 40 edges, whether it's a possible maximum number of the edge for a simple graph. It is mentioned to be simple graph. So it is nothing but NC2. The formula is NC2 for a simple graph. So first that you write it, then you check it. So the maximum number of edges in a simple graph. What is the formula? Simple graph. The formula is nothing but NC2. Now it is given to be N is nothing but 8 vertices. So 8C2. When I calculate it, I am getting only 28 edges. So what is given 40 edges? No. Answer is no is the answer. So it cannot be a 40 edges. So third question. A regular graph, it is mentioned regular graph. Regular graph has a 10 edges and degree to be 5. Find the number of the vertices. So number of the, this given in the question, number of the edges, it is given E to be 10. It's given. Degree, it's mentioned in the question, degree of the each vertices 5. So okay, we know that the formula, so it's nothing but sum of degree of vertices is nothing but 2 times of E. So degree of vertices is given in the question 5 times of n. We don't know. Okay, so 5 times of n is nothing but 2 into 10. So it is 20. So n only we need to find. Number of the vertices only you need to find. N is nothing but 20 divided by 5. So it's nothing but 4. So 4 n equal to 4 is the number of the vertices. Okay. The last question. Find the number of the path of the length n between the two different vertices in K4 if two subdivisions has been given. So the first division, before going with the K4, first K4 diagram, first we need to draw it. So the K4, first K4 diagram I will draw it. So K4. So this is complete K4 diagram. Complete graph. Complete graph always K4. So this is K4. Okay, they did not give. I have drawn with 4 vertices. It's mentioned 4 vertices. Okay, so 2 adjacent vertices. So K4 I have drawn. So first step we have to find the adjacent matrices. So adjacent matrices we need to find it. So what is the adjacent matrices? A matrices we need to find. So A matrices, it is whatever it is communicated, this only I am going to write in a matrix form. 0, 0, V1 to V1, it's not there. V1 to V2 is there. V3 is there. V4 is there. So all 4, 1. Okay, V2, we have to write it. From V2 to V1, yes, it is there. V2 to V2, it's not there. So remaining element is there. Same way V3, it is 1, 1. 0 1, same way last 1 1 1 0. So A adjacent matrices A calculated. Okay, so now it is asked to find for 2 and 3 means A squared you have to calculate, A cube you have to calculate. Okay, so normal matrix multiplication you have to do it. A squared in the calculator you can do it, A cube you do it normal matrix multiplication. Directly now I will write the answer. Okay, so 2 3 2 2 2 2 3 2 2 2 2 3. So now A cube answer I will write it 7 6 7 7 7 7 6 7 7 7 7 6 is completed. A cube, A square and A cube. So what is the first question? When n equal to 2. So the number of the path, the length is asked to be 2 between two different uh, between two different vertices. So it's nothing but 2. Okay. So now the number of the path between the vertices 2 itself. So it's nothing but vertices 2 itself is nothing but 3. length 2, it should be a length 2 from any, sorry, length 2 from any vertex to itself. It's nothing but 3. Everything 3 from own vertices. It's nothing but 3. Remaining everything 2. So that only it is written. Okay, so completed. So for the second subdivision, same way, number of the path of length 3 between two vertices, two different vertices, is nothing but 7. Correct? 7. And the number of the path of the length 2 from any vertices to itself is nothing but 6. Same thing. So completed. Thank you.